Welcome to qnawire.
So this problem wants us to determine the radius of a sodium cubic cell. And so the way that we do this is first find the volume and then use the volume to find the radius. So we'll start with our atomic mass, 22.99 grams per mole. We'll then divide by our radius, 0.97, or our density, 0.97 grams per centimeter cubed. We can then divide by Avogadro's number, 6.022 times 10 to the 23rd atoms per mole. And then we know that since we have a body-centered cubic, we have 2 atoms per unit cell. And so if you'll notice, grams will cancel, moles will cancel, and atoms will cancel. And we'll end up with our answer, 7.87 times 10 to the negative 23rd centimeter cubed per unit cell. And so that is our volume. And so volume of a body-centered cubic is volume equals 4 times the radius divided by radical 3 cubed. And so we can rearrange to solve for r. And so that'll equal the cubed root of the volume, which is 7.87 times 10 to the negative 23rd centimeter cubed. And then we just multiply that by radical 3 over 4, the remaining part of that equation. And we get 1.86 times 10 to the negative 8th centimeters, or 186 picometers. And that is our radius. And so letter B asks us to determine the density if it were a close-centered packed unit cell instead of a body-centered cubic. And so the density of a BCC cell, which is what we have, divided by 2 is going to equal the density of a cubic close packed. And the reason for this is because in CCP, there is 1 atom per unit cell, and in BCC, there are 2 atoms per unit cell. So if we divide this by 2, we'll get the same, or we'll get the correct density. So 0.97 grams per centimeter cubed divided by 2 is equal to 0.49 grams per centimeter cubed. And that is our final answer.